But if you need some help, then just continue watching and I'll give you a few more hints here. So the volume of this box, let's say, is going to be this length, which I'm going to write with a capital L as opposed to that lowercase l, because this is actually a different length. So this length times capital W, this width, right, times this height, which I'm going to label as a capital H, right? Length times width times height. So that's just from geometry. Okay. Now, if you remember doing these problems in class, kind of the more basic problems, it involves calculus, right? So we're going to have to find the derivative of this volume function if we're going to find where its maximum occurs. Well, I can't find the derivative of L times W times H, or I could, but it'd be really messy, right? What we want to do is write it all, the trick is to write it all as a function of x. Okay, so let me try to connect the dots here for you. This would be our capital L, this dimension here. Yeah. This would be our, this here would be our W. And one of these flaps would be a good one to choose. This flap here. They're all the same, but the height of the flap, oops, not X. Kind of gave that away. But capital H. Okay, so length times width times height would be the volume. Now we have to make that, map that onto here. Okay. Well, what would the height be? Let's start with that. What would this height be? You can visualize going from here to here. The height of these flaps is actually X, right? The height of the flaps is X. So that equals X. The length of the box, capital L, is different than this L. That L, lowercase l, remember, represented the length of the original rectangle, which is that. We want capital L, which is that. Well, how are they related? If you look, I can take the original L, and what did we cut out from the length? We cut out an X here and an X there. So we really subtracted 2X from this L to get that L. So our L is little l minus 2x. All right? And similarly, here's our W dimension. That W, the little w, represented the width of the original rectangle. We want to find what we were calling capital W, which is the width of that kind of base rectangle, which is the width of our box. Same principle applies. That W, we can take the original little w and subtract 2x from that. So this big W is little w minus 2x. Okay, so that's the width of our box, that's the length of our box, and that's the height of our box. So let's go to the next page. And let's write the volume as a function of x. Well, capital L is little l minus 2x. Capital W is little w minus 2x. And h, the height, is just x. So we've got the volume as a function of just x. You might disagree with that. You might say, well, what about the little l and the little w? But if you remember, little l and little w are the dimensions of the original rectangle that you were to measure. And these are numbers that you have. Those are constants. They're not variables, they're constants. So little l and little w are constants that you can put in because you measured these. So all you'll have is some constants and x in this volume function. You might want to multiply through here and simplify, obviously. I'll leave that to you. But what you are to do is to use your optimization techniques on this volume function. So I hope this kind of cleared things up for you. If it didn't, send me an email or come to tutorials. This project is going to be due not this coming Monday, but the next Monday. So what would the date on that be? The 8th. February 8th. Monday, February 8th, it'll be due. And good luck. You have plenty of time to ask me questions between now and then. All right.